Alright, let's proceed to the next example for solving the resultant of distributed distributed loads, no? Line loads ito. Distributed normal loads. Yan. So, ano yung principle na ulit? Pag-solve ng resultant. For surface loads, the resultant is just the volume of the loading, ano. And then kapag line loads naman, which is usually the case, no, sometimes to simplify yung analysis, kapag yung surface load ginagawa nating line load siya, no, we will just consider a strip of that of the surface. So 1 meter strip, 1 unit strip, 1 meter strip, or 1 foot strip, no, to para ma-neglect yung width ng yung surface natin, and we can analyze the system as a line load na lang siya. Okay? So let's proceed to this example. For line loads naman, the resultant is just the area of the loading. Okay? Okay, so let's proceed to this problem. Determine the resultant force and specify where it acts on the beam measured from A. So we have this loading. Okay. Dalawang triangular loading, no? So first we need to convert muna itong dalawang area into the resultants. So let's say this is R1, R2. Yung R1 is the resultant of this triangular load. And then R2 is the resultant of this triangular loading. Okay. And R1 and R2 are located. Siyempre may location yan. Anong location ulit ng resultants ng loads natin? Distributed normal loads. For line loads, it's the centroid, no? For both, for surface loads and line loads, the line of action of the resultant load, the resultant force, is located at the centroid of the area or volume. In this case, we have a triangular loading. Okay, so R1 is located where? Dito. So ito yung base ng triangular load natin. Dito siya. So that's 1/3 of 3. So 1/3 of 3 from here, or that is 2/3 of 3 from this side, from this end. So since we are summating moments later on at A, so we are solving kasi yung location ng resultant force from A. So I think it would be best to locate na lang yung centroid natin ng dalawang area from A. Okay, so from A. So this would be 1/3 of 3, or that is 1 meter. Sorry. So this is 1 meter ba? 1 meter. And this is itong R2 naman located from A. Ito yung base niya. That's 1/3 of 6, no? 6 or 6/3, or that is 2 meters from A. Okay. Ayan. Okay, so solve natin R1. What is R1? Area. So the resultant is just equal to R1, the resultant force is equal to the sum of the two resultants. It is R1 plus R2. So R is equal to R1, area ng triangle na first ng triangle natin to. So 1/2 base natin is 3 meters, and then the height is the intensity itself. It is 6 kilonewtons per meter. Plus R2 natin, ito triangle. Again, area ng triangle 1/2, base natin is 6 meters. Height would be the intensity of the loading, which is 6 kilonewtons per meter. All right. So I pronounce R. The resultant is equivalent to 27 kilonewtons. That's the resultant force. No. And then, saan yung location niya from A? So, i-redraw na lang natin yung beam. So, pinalitan natin yung beam. So, dito yung resultant. Pwedeng yung location ng resultant natin ay pwede nandito siya, we do not know. Nasa left ng A or nasa right ng B. So, let's just assume, no? Assume na lang natin na nandito yung resultant. So, yung location niya from A, let's say X. Ayan. So, ito kinonvert natin into an equivalent system na ito. Okay? So, halimbawa, yung resultant natin ay nandito pala sa left ng A. So, ang magkakuha lang doon, the same pa rin yung makukuha natin na value ng X, pero maging negative lang siya. Which means we have assumed the wrong, yung initial assumption natin na location ng R is wrong, dapat nasa left pala siya ng A. So, yan. Let's assume na nasa right ng point A na lang muna yung resultant natin. Okay? So, let's use the principle of moments to solve for the value of X there. Value of X. Yan. So, the moment of R should be equal to the moments of the original force system, yung forces natin about point A. So, R is equal to 27 and it creates a clockwise moment about A, so that's positive. 27 times X, yung moment arm niya. I forgot to equal yung... So, yung moment ng resultant force about A should be equal to the moment or the summation of moments about A. Yan. So, 27 times X should be equal to the moment of R1 about A. So R1 creates a counterclockwise moment about A, so it's minus. So minus, what is R1? It's 3 times 6, that is 18 divided by 2, that's 9. So 9 kilonewtons times moment arm niya from A is 1 meter. Okay. And then moment of R2 about A. So R2 natin is ito ulit 6 times 6 divided by 2. So that is 18 kilonewtons. 36 divided by 2. So that is, so positive siya, clockwise yung direction. So that is 18, I'm sorry. 18 kilonewtons times its moment arm about A is 2 meters. Okay. So X is equal to 1 meter from A. So since positive naman yung nakuha natin na result, na value ng X, ibig sabihin tama yung initial assumption natin na yung resultant ay nasa right ng A. Halimbawa, negative 1 yung nakuha natin, mag-negative lang ibig sabihin nun, R should be nasa left ng point A. Ayan. So that's it. It's how we solve for this problem. Next problem, perhaps the last for this particular topic. Alright, replace the loading by a single resultant force and specifies location on the beam measured from point O. Okay? So, just like what we have done sa first na problem, so if we have these combinations of regular shapes, no? So, natin dalawang trapezoid na loading. So, magandang i-divide natin yan into regular shapes, triangle and rectangle. Or dun yata sa module natin, iba yung pagkaka-divide niya. So, ginawa niyang triangles up Hindi ko alam, 3 or 4 na triangles yun. But let's try to divide it into 2 triangles and 1 rectangle. Ito lang ang pag-divide natin. Oops, is that straight? Wala yung ruler. Okay? So, yan. So, we have the rectangular loading, 2 triangular loadings. So, ito na yung loadings natin. Okay? So, tatlo. We're going to replace this triangular load into a resultant. Its resultant force, let's say that is R1. So, i-convert it into R1. And then R2 would be the resultant of this rectangular load. Of course, it acts at the center. Yung center nito, somewhere here. R2 is the rectangular. And then we also have the resultant of this force triangular loading. Let's say that is R3. Yeah. So that the resultant force is just the sum of the 3 forces. Okay? So. Let's solve for the resultant force. So the resultant force is just the sum, no? R is equal to R1 plus R2 plus R3. So, R is equal to R1. Ano yung R1 natin? Area ng R1. So, 1/2. That is 6 meters yung base natin. Times yung intensity, that is, ano yung intensity nito? So, take note that yung 5 natin ay from this point up to this point. Pero yung triangular load, dito lang, yung triangular load natin. So, which means that itong triangular, ang intensity niya is, so 5 minus 2, that's 3 kilonewtons per meter. Ganon din dito sa kabila. No. Ito, magiging 4 minus 2, so that is 2 kilonewtons per meter na siya. Yung triangular, tapos yung intensity ng rectangular load is 2 kilonewtons per meter. So, the intensity here is 3 kilonewtons per meter. Okay. Plus R2, yung rectangular load natin. Rectangular siya, so that is 6 plus 3, that's 9 meters times yung intensity niya, which is 2 kilonewtons per meter, plus lastly yung R3 natin. R3 is a triangular load, so 1/2, base is 3 meters, intensity niya again, that is 2 kilonewtons per meter. Okay? So R, this is R1. R1 is 9 kilonewtons. R2 is 18 kilonewtons plus R3 is 3 kilonewtons. Okay. So the resultant force now is equal to 30. Add natin lahat yan. So that is 30 kilonewtons. Okay? So, yun na. And then we need to solve also the location of the resultant force measured from point O. So, ito yung point O natin. So, yung i-redraw natin yung beam, hindi na siya straight. My goodness. Basta ganyan na. So the resultant force is somewhere here. The resultant. And it is located certain distance x na lang from point O. Ayan. So, ano yung principle na ginagamit natin para ma-solve yung location niya? Principle of moments. So, yung moment ng r about point O should be equal to the moments of r1, r2, and r3 about point O. Okay? So yung moment ng resultant force about point O is equal to the summation of moments about point O. So we have R creates a clockwise moment about O. So that is positive 30 kilonewtons times X. It's equivalent to the moment of R1 about point O. So R1, ito, R1 creates a clockwise moment about point O. And it is located, ano yung location ng R1 natin? Ito. So ito yung triangle. Ito yung base ng triangle natin. So this is yung location ng triangle. Location ng triangle. Location ng R1 about point O. Eto. So that is 1/3, no? So 1/3 of 6. So 1/3 of 6. So 1/3 of 6 is this is 2 meters. Okay. R2 naman, itong distance na yan. So half ng ano, ito. So that's 6 plus 3, 9 divided by 2 is 4.5. And then later on, yung moment arm naman ng R3 about O. So ito, so 6 plus itong distance na to. So R3 is located 1/3 of 3 from this point. Pero kailangan natin yung distance na to. Okay, what is that distance? 2/3 of 3, which is 2 meters. Ayan. So R3, moment arm niya from point O is 6 plus 2 meters. Okay? So yun na. So moment ng R1 about point O. So we have 9 kilonewtons. So clockwise yung moment ng R1 from point O. So 9 kilonewtons times its moment arm about O is 2 meters. Okay? And then moment naman ng R2 in point O, that is R2, which is 18 kilonewtons. 18 times moment arm niya is 4.5. So that is plus R2 is 18 kilonewtons times 4.5 meters. Plus siya kasi clockwise yung moment ng R3 about point O. No? So clockwise. So R3 times its moment arm from point O, that is 2 meters plus yung 6 meters. So that is 8 meters yung moment arm ng R3. So that is now 3 kilonewtons times 8 meters. Okay, now we are left with the x in the equation. So we can solve for x. So x is 4.1 meters yung location ng resultant from point O. Okay. So that's it. Next chapter na tayo.